We understood some of the aspects of data warehouse in previous class. We'll continue our journey to explore more on the data warehouse and its related concepts. Now the question is, Anna, what is data warehouse?
So it's subject-oriented, non-volatile, integrated, and time-variant storage.
Correct. Used for what?
Decision making.
Decision making. That is a data warehouse. Okay. And we did discuss in length data warehouse, analytics, insight, how does it help the company, all those things, right, Shabna? We did discuss about all those things, isn't it?
Yes,
Right?
sir.
Okay. It's clear. That is a data warehouse. Now, if I ask a question to Vinith, do you look like this, Vinith?
Yes, absolutely.
See?
Just like it.
Just like that. Okay. So if I ask you a question, how many data warehouses will be there in an organization?
By going with the example, it's only one, but there are multiple sources of data from where we are extracting the data.
Absolutely. Usually, any organization would have one data warehouse. Very big organization, we may have a couple of them, but not as that of number of databases will be more than the number of data warehouses for sure. Okay. Now, when we have only one data warehouse, how much of data will be there in the data warehouse, Shabna, in terms of records or in terms of bytes?
Petabytes, yottabytes.
Yeah, a lot of data.
Yeah.
Petabytes of data will be there in the data warehouse. Then the question is, if one person wants only the sales data in a data warehouse, he or she has to scan through all the data, or they will have a sales data readily available. Anna,
So
when
in a data warehouse, it will be available.
it will be available, the question is, does he or she need to scan through all the data in a data warehouse, or they will get only sales data?
So we can get only the sales data because transform data is what is loaded into data warehouse.
Correct, but we may have a product data also, we may have a customer data also, right?
Okay.
The records only pertinent to the sales may not be segregated as such in a data warehouse. If somebody wants only sales data, a particular data, he or she has to scan through all the records of data warehouse. Potentially billions of records. Okay. That is a waste of time and energy. So with that, there is an issue. To answer that question, we have created a data mart. Vinith, what is data mart according to you?
We discussed, there is a sales data, there might be some behavioral data, there might be some other data. All this data should be in a different storages.
Okay, very good. Okay.
Like in a bucket, we can say.
Correct. You are hinting in a right direction. Okay. So data mart is a subset of the data warehouse. Okay. And usually oriented to a specific business line, maybe only sales data, maybe only customer data. Okay. Maybe only product data. So how does it help?
So then we can fetch the data based on the business needs easily. So
Absolutely. Okay. With this, what happens is you will be able to impose the access control strategies. Those who are in a sales team only provide the access to the data mart of sales team. Okay. Right. And also it will help in speeding up the queries by reducing the number of records it has to scan. Make sense? So, Sabna, what we are trying to do here is data warehouse is the big monolithic data store. In a way, as Vinny said, it will be one in an organization. But if somebody has to search through this, they have to scan through so much of records, right, Shabna? Instead of that, we create. Yeah, go ahead.
So that's why we subject oriented.
Even though it is a subject oriented, it will have multiple records. Now, it will not have a business line specific segregation. That will be done by a data mart. Data mart is a subset.
So, sir, can we say data warehouse is a kind of collection of data marts?
Yes, you can say that.
Okay.
It is a subset of the. Okay. So that is a data mart. Okay. I just wanted to introduce these things to you. But whenever, if you remember the transformation, if you see, these are the data marts. Okay. Then comes the BA layer. Okay. Wonderful then. So now we understood the data mart. Let us move forward. Now, if I ask a question to any one of you. Any one of you can answer this. How do we store the data in a database?
In
The
table.
table.
In a table. Okay. So we stored the data in a database in a table. A very straightforward answer. Okay. Now within the table we have rows and columns. What happens is, if I ask you a further question, how do we store the data in a data warehouse? Like, where do we store the data? In a table. But how do we store the data? We don't have any folder in the data warehouse. Okay. So we store the data in tables, and those tables are fact tables and dimension tables. Okay. So these are the different types of tables within the data warehouse. Okay. See, what we are doing is, we are talking about the data warehouse, which is a large store, subject oriented, integrated, time variant data store for helping the management to take the decisions. And within that, the data is stored in the tables. The type of tables in the data warehouse are dimension tables and fact tables, right? When it's very simple, right?
Right, sir.
Okay. So now let us understand the dimension tables and fact tables. Okay. We already know this. Data warehouses are built using the dimensional data model, which consists of fact and dimension tables. Okay. So when you look at this diagram, when you have a business where in the business you have a descriptive entity. I'll take an example. It will be a bit more clearer for you guys. And we have a business number. Dimension is the data that explains the business numbers. On the other hand, facts are the business numbers. Facts are quantitative in nature. Okay, you guys are with me? So data warehouse has dimension and fact tables. Dimension tables are descriptive entity. Entity is nothing but a table. Those who have watched our SQL or DBMS videos, they would know that. Okay. So descriptive table or entity are the ones that explains the business numbers. Okay. Fact table should have a quantitative data, numerical data. Okay. Out of the data which is coming from the various sources, all the quantitative data, numerical data will be put into the fact table. All the data which describes the fact tables are put into the dimension. Okay. These are mere tables. Only thing is, based on the attributes, we are segregating those tables into fact tables and dimension tables. Now, what I will do is, before I go through this, let me take an example. Now, in this example, these are the different fields or columns in a database, okay, gathered from different sources. So now, my question to Anna is, which are the columns in this which are numerical in nature?
Numerical. Date,
Okay.
unit price,
Mhm.
sales amount,
Mhm.
transaction number.
Okay. So you are almost there. When I say numerical in terms of business numbers, so these are the ones. Okay. Quantity is a numerical, 1, 2, or 3. Unit price is a numerical. Sales amount is a numerical. Transaction number is a numerical. Okay. So we don't call date as a numerical. Okay. Because the number, obviously date is formed of the numbers, but that is not, we'll not be able to add the dates, all those things, right? Okay. So that way, in that regard, we'll not call that as a, okay. And these are texts, store number, product, these are the texts, right? Now, Vinit, based on what we discussed, which one of these are the attributes which are describing the facts and which are the facts?
Okay, the data that explains the business numbers are called dimensions. Business numbers, transaction, sales amount, unit.
The dimension describes the business numbers. These are describing this. Yes or no?
Okay.
And
The
facts are quantitative, are numerical values, right? These are numerical values, right, Vinith?
Yes, I got it now.
So these are the ones which will get into the fact tables. These are the ones which will get into the dimension. Okay, Anna, it's clear?
Yes, sir.
Now with the example, it is bit more explicit, right? It is bit more easy. Okay. So here, if you can see further, these are the columns which are descriptive in nature, because these attributes describe these things, right? Without these attributes, these will not have values. These are the numeric values. So now all these things will establish the relationship by the store to the quant, these values, the dimensions. So in a way, what happens is, this is a all the order, amount, quantity gets into the fact table, and customer name and all those things will get into the dimension. Dimension 1, dimension 2, dimension 3, dimension 4. Okay. So, and then you may ask, what are these? You need a primary key, right? You need to establish the relationship between the fact table with the dimension table, right? That is where we have a foreign. Okay. Now with this example is clear to all of you. Any questions here?
No, sir.
No questions? It's clear? Vinith,
Yes.
Anna? Okay. Now that we understood the fact and dimension with the example, let us understand bit more about the fact tables and dimension tables. So fact table is a quantitative piece of information about the business process, isn't it? We already have seen the example for that, right, Parveen? Pieces of product is sold. What is the price at which it is sold? What is the total price? What is the total quantity? That is a fact. And it is also called as a measurement or mate. Whenever we measure comes into picture, the numerical values comes into picture. Okay. Fact table is the central table in the schema, which contains facts and connected to the dimension, which I already shown you. Because it has to be connected to all the dimension tables, it is placed as a central to the scheme. It is a primary table. Without fact table, there will not be any data warehouse. In the data warehouse, you need to have fact table, and it has a measurement and facts, and also it has a foreign key to the dimension table, which you have already seen. Because when we have a fact here and dimension here, in order to make these two tables talk to each other, we need to have a foreign key. If you want to understand about the keys, please watch our RDBMS and also SQL videos in the YouTube. So we have to have a foreign key to the dimension table. Okay. And fact table is one of the very, very important table for analysis. So far so good. Vinith, what are we talking at a high level?
We are talking about fact tables,
As a part of what?
Data
data
warehouse
mods,
table.
data warehouses, and data mods.
Dimension model.
How data is stored in data warehouse.
So yeah, excellent. Okay. We are talking about the fact table. Fact table is a part of the data warehouse. Okay. That is what we are talking. And also facts are nothing but measurements, and also there's a foreign key to the dimension table. Okay. That is the fact table. And also one important observation is usually fact table will have large number of rows. As compared to the dimension table, fact table should have large number of. Okay. That is about the fact. Now coming to the dimension table. We already know dimension table is a table that stores the attributes or dimensions that describe the objects in the fact table, which we have already seen. Product is describing the quantity and the price. Without product, there is no quantity and price. Okay, that is the thing. So these are the descriptive entity which provides the perspectives for the users to view the business numbers. Okay, without this is not there. Okay, that is a dimension. So as we already understood, fact tables would have large number of rows. On the other hand, dimension tables will have small number of. Okay, and they are used to provide the context to the data in the fact table, because in a way these are also called as descriptive entities. Okay, entity is nothing but a table. So now the question is, does the dimension table have attribute? Any idea?
So columns in the table.
Absolutely. Columns is nothing but that. My question is, does the data warehouse has attributes? Not the data warehouse. Does the dimension table have attributes? Do they have attributes?
Yes.
Yes.
Yes, obviously. The dimension table should have attributes. Attributes are nothing but columns. We already know that. Okay, Shabna, does the dimension tables have a columns or not?
Yes.
They do, right?
Yes. Yeah.
Yeah. Okay. Now the question is, in addition to the existing columns, okay, the dimension tables contain a unique key columns that uniquely identifies the each row in the table. Okay, they are the columns which will uniquely identify the table of a dimension or surrogate key and alternate. So in addition to the existing attribute columns, dimension table contains the unique key column that uniquely identifies each row in a table. As we have a primary key in each of the table in a database, we have a surrogate key and alternate key in the dimension table. What is surrogate key? Anyone?
Sir, it is a key by which the system itself is generating to identify the unique records. Yeah.
Yes, okay. Surrogate means it's kind of a artificial, right? Surrogate methods. You guys are getting, na? In the same way, whenever the table do not have a proper primary key to identify the row uniquely, that is when surrogate key comes into picture. Surrogate key is a unique identifier for each row in the dimension table. Okay, so usually it is generated automatically from the DB image. Why? Whenever there is no key which will uniquely identify the rows, that is when surrogate comes into the picture, and it is usually generated automatically. Okay, in a way that's specific to the data warehouse, and they help to maintain the consistency and accuracy in the data. Okay, if there is no proper key which will identify the row uniquely, then there is a problem, right? We'll not be able to retrieve the data properly. That is where surrogate key comes into picture. And which is the other key?
Alternate key.
Alternate key. Okay, so what happens is the data warehouse would get the data from the data sources, right? Okay, now I mean, in order to get some kind of a tracking back to the sources, so in that cases, as I said, traceability between the data warehouse and the source systems. For that, they will have an alternate key. Okay, in order to establish the or maintain the traceability between the data warehouse and the source system, they will have an alternate key. Okay, as I said, we have explained really well the different types of keys in the SQL and RDBMS lectures as a part of our YouTube. Please do watch that. And these are specific to the data warehouse. That is the reason I'm kind of dealing with them here. I'm explaining them here. Okay. So any questions here from anyone? You guys are clear about fact table and dimension table?
Yes, sir.
Awesome then. Okay, let's move forward. Now, if I ask a question to what is the schema, Anna, in general?
So it will show the structure of the tables.
Okay, in a way, structure. Okay, so schema is in a way framework. I mean, what you said is also right. It's a framework that helps us to organize and interpret the info. Can I say that schema is a framework that helps to organize and interpret the info? Okay, in a generic way.
Yes, absolutely, sir.
So coming to the data, the schema defines how the data is organized and how the relations among them are associated. Okay, this also we can call it as a schema. Now, what is the database schema? Anyone?
It is a structure of the database telling about the number of columns and its data types and its size.
Okay, so database schema is considered as the blueprint of a database, which describes how the data may relate to other tables or other data models. Okay, so when you go to the database, you may have multiple tables in a database, right? So table 1, table 2, table 3, 4, 5, 6, right? How these tables are related to each other. That is what is established as a part of the database. Now, what is a data warehouse schema then?
Data warehouse, many tables are there. In that, how all these tables are related together.
Okay, then what is the difference between data warehouse schema and database schema?
Schema of schema.
Okay, data warehouse is schema of schemas. Okay.
In data warehouse, tables will be from multiple sources, no, sir.
Shabana, go ahead. Okay.
Schema about the fact table and the dimension table.
Absolutely. Basically, again, the data warehouse schema is how the data will be stored and managed in the data warehouse. Organization of how the data is stored and it relates to the other data within the data warehouse. The same thing, instead of database, change the data warehouse here. But as our Shabna said, here it is nothing but how the tables, how the fact table and dimension table are arranged based on, we have three types of schema in data warehouse. You guys are getting it, right? Based on how the fact and dimension tables are arranged, there are three types of schema within data warehouse. One is star schema, because Shabna wanted to watch a moon, we are giving her a star also. Then I heard our Vinit likes a snow, right? Do you like a snow, Vinit?
I love.
That is the reason we are having a snowflake schema. And
Yes.
then our Muttumina likes constellation, like galaxy. Okay, so we have a fact constellation schema. We have a star schema. We have a snowflake schema. We have a fact constellation schema. Based on, we have these schemas, Parveen.
Based on fact and dimension tables.
How the fact and dimension tables are arranged. Based on that, we have this schema. And there are other aspects also, but at a time, I'm simplifying it for you. Wonderful then. So, is it making you think something? Vinit, Parveen, Anna, Muthuminar, any questions? Let us understand these schemas at a high level. You guys can drill down a bit more in detail, but I'll tell you guys at a high level. There are so many concepts here, right? Vineet, Parveen?
Yes, sir.
Okay. So very simple. Star schema, as the name suggests, the fact table is in the center and the dimension tables are arranged around the fact table, giving a appearance like star.
Star.
That is the reason it is called as a star schema. And there are a couple of other important points in the stars. They are dimension tables are denormalized to maximize the performance. The normalization, if you guys have gone through our videos, normalization is nothing but decomposing the tables to remove the redundant data. That in the database, we usually normalize the tables. But in case of star schema, dimension tables are denormalized to maximize the performance. Any idea why denormalizing helps in performance? Anna, any thoughts? When any idea from anyone? Parveen, Vineet?
If we are normalizing the tables, then we are utilizing some computes. But when we are just using denormalized table, then we are not doing anything. We are just using the tables in a condition as it is there.
So what happens is when you say normalization, the one table is decomposed into some 2 to 3 tables, okay, to remove the redundant data. Now, in order to get the information of what we want, we may have to join these tables, right? The join operations are expensive, costly, okay? So please go through the normalization videos in my playlist, okay? In case of star schema, dimension tables are denormalized to maximize the performance. When you see denormalize, you will get all the data in the same table. You will avoid the join. That is the reason whenever you denormalize the table, it will improve the performance. Whenever you have a ad hoc queries, that is when you can use the star schema, okay? So, and this is the simplest and very effective schema in the data warehouse. So this is the example. We have a sales fact table and we have product dimension, we have branch dimension, we have customer dimension, we have country dimension. Okay. So we have a one fact table centrally and all other tables. This is the star schema. Then what is snowflake schema? Any idea? Anyone? What is
It
snowflake?
would be in the structure of snowflake.
Yes. So snowflake schema would be like a snowflake. Okay. What happens is if the snow falls like lot of snow falls, you'll get a structure like this, right? This, right? Okay. So snowflake schema is an extension of a star schema where the dimension tables are connected to one or more dimension. Anna, why do you think there are one or more dimensions here? What may be the reason?
So again, for normalization.
In case of snowflake schema, dimension tables are normalized. When I say normalize, when I say decomposing, I'm talking about splitting a table into multiple tables. Okay? That is what is happening. That is the reason we have dimension tables are normalized. We split up the data into additional tables. In snowflake are slower as compared to the star schema. Any takers? Anna, Parveen, anyone?
Fast.
Say when the data is denormalized, then the queries are fast because the data is there in the same table. When the data is normalized, what happens is the data is stored in multiple tables. If you have to get the data from all these tables, you have to again do the join, right?
Yes.
What does it mean then?
It's slow.
It is slow as compared to the star schema. Okay? You guys got it now?
Yes.
Okay. So snowflake schema example. See here, product dimension is split into 2 tables. Okay. Category is made in one more dimension. Okay. Country dimension is split into one more dimension. We have a central fact tables, but you have multiple dimension tables. Got it? Let us look at the fact constellation schema. What is fact constellation schema, Anna?
So maybe there'll be a lot of fact tables.
Yes. Okay, you are right. Okay, not lot, more than one. Okay. As you rightly said, the fact constellation schema has a multiple fact tables having some common dimension tables. So dimension tables are shared between the fact tables. So since we have a collection of, this is also called as a collection of star schemas, and it is also called as a galaxy schema. So as I said, This in a way allows the dimension tables to be shared among the different this one. Okay. This schema is definitely more complex than the star schema and snowflake schema because it has a multiple star schemas. You have a sales fact table, shipping fact table, and this dimension table is shared between these two. Is it clear? Fact translation schema.
Yes, sir.
Okay, wonderful. We discussed so many important aspects today. That's all for now. Like and subscribe and turn on notifications for future videos. Thank you.